okay? 8.5 is called the counting principles. So this is the beginning of probability because this is where we figure out how many ways something can be done. And then probability is like, what's the likelihood that this happens out of that total amount of ways? So the counting principles is figuring out like what could the outcomes be. So there's this. Oh, that's was my original plan. This we're actually going to skip for now because I think it gets confusing. We'll talk about it tomorrow when we get into probability. We're going to skip this slide and we're going to go to example 1 because you don't need to know anything to know how to do this. This says determine the number of ways in which a computer can randomly generate one or more such integers or pairs of integers from 1 through 15. So the general way of this is, and we're going to start to learn tricks to kind of like narrow down the work of it, but think about what it would look like. So if a computer is randomly generating one or more such integers or pairs of integers from 1 through 15, that means that that would be one of these things, let's say, okay? If I do from 1 to 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, okay? And A is just saying the number of ways in which a computer can randomly generate one or more such integers such that it is an odd integer. So if I look at this set, I went all the way to 15. If I look at the set of numbers, sometimes it's easier to do without the set, but if you need the visual on it, I'm specifically looking for an odd integer. So how many odd integers are between 1 and 15, including 1 through 15? There's 8. 1, 2, 3, 4, 5, 6, 7, 8. Wording on these questions becomes extremely important, okay? For example, from 1 through 15 means I count 1 and 15. If it said between 1 and 15, I don't count 1 or 15. If it said from 1 to 15 inclusive, it also means include 1 through 15. So you're going to start to really analyze the wording on these things, okay? So if it says determine the number of ways, I'm just counting, which we just said there would be 8. If it said build your sample space, my sample space is 1, 3, 5, 7, 9, 10, 7, 9, 11, 13, and 15. That's your sample space. All right, B says an integer that's divisible by 4. So same sample space, right? Which of these would be divisible by 4? 4 itself. 8, 12. How many is that? 3. There's 3 there. Wait for it. Okay, so something we're going to pay attention to in which there is one, like you're trying to do one thing and then another, for example, would be whether it has replacement or not. So the very first thing you're going to think of is there replacement? Meaning, is there a fresh set of numbers every time? Or has your set been altered in some way? So with replacement means you're starting with the same full set every time. A randomly selected number from a computer will be with replacement. You will start with all the sets of numbers every time, okay? If it doesn't have replacement, that means that what you're pulling from has been altered, for example. In that case, so let's say you're pulling a piece of paper out of, like I give you, like for example, when you pick your seats, right? If I came up to you with a mug and you pulled a piece of paper out and you kept it, that is without replacement because this set does not include what you first got. Does that make sense? But if it was like a take a rock out, put it back, that's with replacement. If it's a spin the wheel and you land on your name, but your name does not go away, that would be with replacement. If you spin the wheel and it takes you out, now it's without replacement. Does that make sense? Okay, so one of the very first things you're going to say is like, what's it looking for overall? And if it's 2 events, if it's you do this and do this after, then you have to consider if it's been replaced or not. Any randomly generated from a computer will be like a fresh set. Rolling a die, fresh set. Flipping a coin, fresh set. All of those are with replacement. All right, so example 2 says 8 pieces of paper are numbered from 1 to 8 and placed in a box. One piece of paper is drawn from the box. Its number is written down and the piece of paper is returned to the box. Then a second piece of paper is drawn from the box, and its number is written down. Finally, the two numbers are added together. How many different ways can the sum of 12 be obtained? So if you want the visual, 1, 2, 3, 4, 5, 6, 7, 8 are all the pieces of paper. God bless you. So I italicized it to like give it attention this time, but eventually they will not be italicized. You got to pay attention to certain things like this. But note that it says it is returned to the box. So if I take something out the first time and then I go to take another thing out the second time, is it the same set I started with? Yes, because I put it back in the box. Does that make sense? So we're saying the first time I can pick 1 through 8, and the second time I can also pick 1 through 8. And the goal is to get something that would sum to 12. Instead of starting from the smallest numbers when you do these things, start from the biggest numbers because usually you'll get to a point that stops. So meaning, let's say I picked an 8 from the first one. What could I pick from the second one that would add up to 12? 4. So 8 and 12 is one combination. Hey. 8 and 4 is one combination. That gives me 12. What happens if I pick a 7? 7 and 5 is a combination that would give me 12. I did circle that. What happens if I pick a 6 from the first set? 6 and 6 would give me 12. Now 5, 7, 4, 8, 3. Nothing. Not possible. That's why I start with the biggest and work my way down. Okay? So the combinations you could get, that's all terrible written down, were 8 the first time and 4 the second time, 7 the first time and 5 the second time, 6 and 6, 5 and 7 and 4 and 8. So there are 1, 2, 3, 4, 5 ways that we can select two numbers that are, when added together, the sum would be 12. Good so far? Okay, so now go to example 3. It should look very similar. What do you notice is the only thing that's different? Not returned. So if you think about what we just said, we said if we get 8 and 4 and 7 and 5 and 6 and 6 and 5 and 7 and 4 and 8, this was the set that came if I did replace it. What doesn't work anymore? 4 and 8. Nope. If I get an 8, the 4's there. That works, right? If I get a 7, the 5's still there. But if I pull out the 6 and I don't put it back, is it possible for me to get another 6? So we eliminate this option, and now there are 4 ways. Does that make sense? Yeah? So you are assuming I pulled the 8 the first time. Is there a 4 left in that box? Yes. Even though I'm holding on to the 8, there's still a 4 I could pick. If I pull a 7, I'm holding it in my hand, there's still a 5 I could pick. But if I pull a 6 and I'm holding it in my hand, there is not another 6 in that box for me to pull. Does that make sense? Okay. All right, the fundamental counting principle, a fancy word for a lot of things you already know, says if E1 and E2 are 2 events, and by event this would be flipping a coin, rolling a die, pulling a piece of paper, drawing a rock. Any of those are called events, okay? The first event, that's a T that's missing. One of these years I'm going to remember to fix these. Okay, the first event, E1, can occur M different ways, and after E1 has occurred, E2 can occur M2 different ways. The number of ways that 2 events can occur is by multiplying the number of ways from the first one times the number of ways for the second one. So what this means is I'm going to take whatever my first event is. Let's say I'm rolling a die twice, okay? And let's say, like I just want to roll any number on my die. How many different ways can a number be rolled? 6 different ways. So if the first time I roll a die, there are 6 ways. And then the second time I roll a die, there are also 6 ways, which means there are 36 combinations of numbers that I can roll because there are 6 in the first and there are 6 in the second. And that is way faster than saying I could go a 1 and a 1 and a 1 and a 2 and a 1 and a 3 and a 1 and a 4 and a 1 and a 5 and a 1 and a 6. And then I can do a 2 and a 1, a 2 and a 2 and a 2. Like, you don't want to do that. You want to figure out all the outcomes you can get from the first event all the outcomes you can get from the second event and then multiply them together. Now, it doesn't have to be the same kind of a thing either. I could say I'm going to roll the die and I'm going to flip a coin. What are all the outcomes I could get? Well, from rolling the die, what are the outcomes? How many? 6. From flipping the coin, 2. So there are 12 different outcomes you could get. You multiply them together. Does that make sense? Okay. So example 4 says, how many different pairs of letters from the English alphabet are possible? Long way. And this is what standardized tests love, because you could waste a crap ton of time on this. First of all, how many letters are in the alphabet? Good job. There are 26 letters in the alphabet. So I could say A goes with A goes with B. A with B, A with C, and I can count them all the way down, right? Or I could say if it's a pair, here's letter 1 and here's letter 2. How many letters can go in letter 1? 26. And how many letters can go in letter 2? 26. Did it say they couldn't be a repeated letter? No. So if it said repeated could not be, then what is the second? 25. We've eliminated whatever we picked the first time. I don't know what it is, but if it was A, I can't use A again. Now there's only 25 options. Does that make sense? So then this is 576, I think. This is where your calculator is going to come in handy, because we're not going to do 26 times 26. Okay? I think that's right. Right? Is that right?
So what would you multiply by the second one?
If you couldn't repeat it, then you assume you got one the first time, whatever that one is, and it doesn't matter which letter it is, that can't be used again. So the second time, that would be like without replacement. I took it out. What's left is 25 numbers. Yep. I was going to say I'm doing something wrong there, right? Because 625 is 25 times 25. Okay, yeah.
I'm like really confused.
All right, example 5. A combination lock will open when the right choice of 3 numbers from 1 to 30 inclusive. What's inclusive mean? Including 1 and 30, good. Is selected. How many different lock combinations are possible? So first of all, it's 3 numbers. This is like your little twisty thing on your, right? Your actual one. There are 3 numbers. It doesn't say 3 digits. It says 3 numbers. So here's number 1. Here's the second number. I should have said first number, not number 1. And here's the third number. Wait for it. All right, so there are 30 numbers I could fill the first spot, 30 numbers I can fill the second spot, 30 numbers I can fill the third, and then we multiply them out. 27,000 is the answer. It says in a certain state, each license plate number consists of 2 letters followed by a 4-digit number. How many distinct license plate numbers can be formed? Distinct just means different, so obviously the whole entire thing can't repeat, okay? And this is where I would challenge you to stop thinking as 4-digit as in, like Marisol said, 9,999. Yes, that's the highest 4-digit number you want to do, but you also have to include 0, which is why it's easier, I think, separate them out as 4 1-digit numbers, especially because you're going to get ones that have like telephone things. That's the next kind of question, where you'll see it has some things you have to change. So it's 2 letters. Each letter gets its own space in my brain, letter 1 and letter 2. And then a 4-digit number, each digit gets its own space. So what did we say how many letters there are? 26. How many letters would be for the second one? 20. Does it say anything that a letter can't repeat? No. So 26 again. And then digit numbers. How many 1-digit numbers are there? 10. No, there's 10 because 0. So 0 to 9 is actually 10 numbers, right? So it's 10, 10, 10, and 10. And then you would multiply it out. We know 26 times 26 is not what I gave you originally because that was wrong. It is 676. And there are 1, 2, 3, 4 zeros. So it's funny, like, not funny, but like you can kind of overlap your summation stuff, like top minus bottom minus 1 is how many you know is in a set. It's the same as max minus min plus 1. So like 9 is the highest you can get, 0 is the lowest you could get, 9 minus 0 plus 1 is the amount of digits in that set. So if you think about it that way, it's the same. If it was 1 to 10, 10 minus 1 plus 1 is 10. So it kind of overlaps with the summation rules. Ariana?
Yeah, where do you get 26 and 10?
26 is the number of letters in the alphabet. 10 is the number of digits that are 1 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
So you have to do that whenever it says letters.
Well, letter would be 26, yeah, and then numbers, yep. All right, a permutation. So actually, remind me, I'll go back to the telephone thing because it's on the homework, and sometimes you guys get confused on that one. But permutations, okay? If you took geometry honors, that word might sound slightly familiar. Permutation and combination, we did do it. It's been a while, but we did it, if you had me at least. These are ways that you start to figure out. What your options are and what you do with them, okay? The first is a permutation. And in a permutation, the order in which you put things is important, okay? So, for example, if I just took these 6 people and I pulled them up out of their seats and I lined them up, kind of like if I was to give all of you seats, but we'll simplify it by just 6 people. If I were to line these up and I wanted to put them in specific order here, okay? The first person I grab, let's say I grab Sebastian first and I say, Sebastian, pick a seat. How many options does he have? 6. So then Sebastian sits in the seat. And then Daniel goes next and I say, Daniel, pick a seat. How many are left? 5. And then I go to Ethan and I say, Ethan, pick a seat. And how many are left?
4.
And then it would be for Austin, 3. And then Gracie.
2.
And then Angel.
1.
What just happened to that number?
It got smaller and smaller and smaller.
It got smaller by 1. What else do we use that gets smaller by 1?
0.
In math. What's it called when you multiply something by itself and then 1 less? A factorial. So when order matters, we take the number of things we're trying to do and we put the exclamation mark behind it. So if 32 people walked into a room and I wanted to figure out how I could arrange 32 people in a specific order, it is 32 factorial. If I am placing objects on a shelf and I want to figure out how many different ways I can place those objects on a shelf, it is the number of objects factorial. If I'm arranging a picture on a wall and I want to know the number of ways I can arrange it, it is the number of picture frames factorial, okay? So that's where that factorial comes back into play. So when it says literally how many ways can 10 objects be put in order, that answer is 10 factorial. And you will answer it, you will type it in your calculator. That's why you'll get a calculator in those kinds of questions. And it would be 10 factorial. Does that make sense? Yes? Okay. So order is important in these. If you're talking about 10 people finishing in a race, how many ways can those people finish in a race? It is 10 factorial, okay, where order matters. So find the number of permutations of the following letters, A, B, C, D, E, and F. How many letters are there? 6. So this would be 6 factorial. Let me get my calculator because it'll eventually get bigger. And remember, it's under probability. So math, arrow over to probability, go down to your exclamation mark, 720. Still good? All right. Permutations of elements taken at a specific time. So now this is saying you have a big set of people. So for example, if 30 of you lined up at the front of the room, but I only wanted to figure out how to fill 6 seats. So I'm not filling all 30, which would be 30 factorial. I'm only filling 6 seats. Or if you're talking about a big heat of people running in a race and you're trying to figure out how many different ways can they finish top 3. So from your big set, you're only talking about a specific part of it, okay? And the way you do permutations taken a certain amount at a time has this symbol. I call it PNR, but it's permutations. Number N is the total set. R is how many you're trying to fill or place. So this number will always be bigger than this number. N is always bigger than R. They could be equal, in which it would be the same as a permutation, but that defeats the purpose of doing it this way. Again, N being the total number of things in that set, and R being how many you're taking at a time. Example 8 says find the number of permutations of 8 horses taken 3 at a time. So my 8 is my big set. This is my N. And my 3 at a time is my R. And P8, 3 is what the notation would look like. And it is 8 factorial over 8 minus 3 factorial. And we would simplify it, 8 factorial over 5 factorial. and 8 factorial. I would break down until I hit 5. 8, 7, 6, 5 factorial. And it'd be 8 times 7 times 6. So if those numbers are like small enough to do without the calculator, there are times in which you'll be asked to do that without a calculator. For the most part, they still stay pretty big. I'll give you the calculator. And then I'm also going to show you where to find that exact notation on your calculator. So if you have your graphing utility, take it out. If you have your graphing utility, take it out. All right, so I'm going to do B by literally plugging it into the calculator. That would be 6 factorial over 6 minus 2 factorial. I could continue that way. Or if you go to math and you arrow over to the PROB, which is where your factorial is, right above it, you see NPR. Hit enter, and it gives you the little boxes. 6 goes on the left, 2 goes on the right, and we hit enter. Every scientific calculator has that. Sometimes it's in different spots and we have to find it. The older calculators will not give you the subscript little boxes. For those, you have to type in 6, then you go math, then you go PROB, and then you go NPR, and then the 6 will be before it, the 2 goes after it, and then you hit the equal sign. So the older ones still do it, they just do it in a different way. And scientific calculators will still do it, they just do it in a different way. Questions? Distinguishable permutations. And distinguishable permutations is if something in that set repeats. So a lot of times they'll do this with words with a repeated a repeated letter, okay? Like just the word impossible. Like if I count, you would count how many total letters there are, and that goes in the top. So total goes in the top. And in the bottom, every letter that has a repeated letter, we account for. So let's say I use my last name, C-H-R-I. Okay. First of all, how many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 factorial goes in the top. And then how many C's are there? 1. We don't worry about it. How many H's are there? We don't worry about it. How many R's are there? 2. So I do a 2 factorial for the R. How many I's are there? 2. So I do a 2 factorial for the I. How many S's are there? 3. So it's 3 factorial. W's only once. I already did the I, I already did the S. There's an E once. And I already did the R. So if you want to list the letters so you make sure you don't repeat them, go for it, okay? But I only want to include the ones that repeat because otherwise it's just 1 factorial and that's 1. You can write it, but you don't need it. Yeah, the order doesn't matter. Yeah. Okay, so now if I didn't have a calculator, this gets a little bit trickier, especially because it's 11. I wouldn't give you something that, if you didn't have a calculator, wouldn't have something this big. But I would say 11, 10, 9, 8, 7, 6, 5, 4, 3. I'd go to the biggest number. So I could cancel those out. But then I still have 2 times 1 and 2 times 1. And I could simplify. I could say this 2 goes into 4 twice. I always start with the smaller because they're more likely to get eliminated. 2 times. And then 1 goes in. 2 also goes into 2 1 time. And then I could take and multiply 11 times 10 times 9 times 8 times 7 times 6 times 5 times 3. Again, I wouldn't make them that big if you didn't have a calculator. Or literally type it in your calculator like this. So I build my fraction. I do 11, math, probability. Go to your exclamation mark. Then I over 2 times 1 is probably easier just to write 2. Times 2 times 3 factorial or times 3 times 2. You can write it out either way. And my answer is 166,320. I wish I had a short name. 1,663,200 different ways to rearrange the letters in the name. That's the idea. Good? All right, so example 9 says how many distinguishable ways can the letters banana be written? How many total letters? Good, so 6 factorial goes in the top. B only has 1. I don't need it. A has how many? 3. I'm going to cross out the A. N has how many? 2. And I already used the A in the end. So this would be 6 times 5 times 4 times 3. Those are going to cancel. And then 2 times 1. So the 3's are gone. 2 goes into 4 twice. And it's 6 times 5 times 2, or 60. Thank you. All right, last thing we're going to talk about is combination. So there is permutation and there is combination, and this is where I would say the hardest thing comes from distinguishing the difference between them, okay? So remember we said permutation order matters, right? If we're doing first place, second place, third place, that's a permutation that matters. If we're saying how many ways can I put you in order in seats, then that's a permutation order matters. Combination order does not matter. So for example, if instead of getting first, second, and third, we had a podium in which 3 people go, and you just want to know if you make the podium, that's a combination. But if you are finishing first, second, third, that's a permutation. If I have a bench up here and I'm saying how many different ways can I fill a bench with 3 people, the order doesn't matter. That's a combination. Whereas if I had 3 separate chairs and I wanted to rearrange you, that's a permutation. If you are, let's say you're running for office, and there's a president, a vice president, a secretary, a treasurer, and there are 10 people running, and you want to figure out how many different ways you can make those spots, that's a permutation. Whereas if I said, here's a board of people, you're on the board, there are 5 spots on the board, and it doesn't matter which one you're in, it's just a board, that is a combination, because order doesn't matter. A combination has this formula. We call it CNR. N is still the number of things in the set. R is still the number of things you're trying to fill. But it is n factorial over n minus r factorial times r factorial. So we add this on. The number of combinations will always be less than the number of permutations of the same set. Because combinations we divide by the r at the end. So if it says how many ways can numbers be taken, that says numbers, letters be taken from the alphabet 3 at a time. So I'm literally just grabbing 3 at a time, and it doesn't matter first, second, or third. This is a combination because ABC would be the same set as BCA would be the same set as CAB. Together they make up the same one. So this would be 20, this would be C, 26, because that's how many letters, taken 3 at a time. And in your calculator under that same menu, under PNR is CNR. It's also there. All right, last example. In how many different ways can 3 letters be chosen from the letters A, B, C, D, and E? The order of this elements is not important. Obviously, it's going to baby step it in. Eventually, those won't be there. Like those words won't be there. So you have to know that it doesn't matter. And this is a combination. How many letters are in A, B, C, D, and E? 5. So the 5 goes on the left. How many are you trying to pull from it? 3. So it would be 5 factorial over 5 minus 3 factorial times 3 factorial. So I get 5 factorial over 2 factorial times 3 factorial. This is something you could see without a calculator. This is 5 times 4 times 3 factorial over 3 factorial, and then 2 times 1 times that. The 3 factorial goes away. 2 goes into 4 twice, and yes, it's 10. So you can see that both ways, and I don't think it was an ACT, it might have been an SAT, but one of them gave a specific question that literally said, find this. And if you don't know what that is, it's super hard, like how on earth would you figure that out? But now you know you have a button in your calculator that does it. You could literally go to that button and do it, okay? It's like a freebie.
I'll use that on Saturday.
Yeah. Somebody's like, it had CNR on it. I was like, really? Not even like try to figure out to use CNR. It literally said that. Yeah. All right, B, a standard poker hand consists of 5 cards dealt from a deck of 52. How many different poker hands are possible, and order is not important, right? Like when you go to, if you play poker and you go to lay down your hand, you put down your 5 cards. Yes, the order of them is important to get to a specific suit, but if somebody hands you an ace, or well, let's say they hand you a 9, a 10, a jack, a queen, a king, or they hand you a 10, a jack, a king, a queen, a 9 in that order, it's still the same hand, right? So that's what this means. So if what's my full set? What goes on the left? How many cards are in the full set? 52. How many am I taking out of hand at a time? 5. This, you would not have to do with a calculator. That's a very large number, okay? So I would go, you would not have to do it without a calculator. So if you go to math and you go over to PROB, underneath the NPR is your NCR. 52, 5. $20,358,520 different hands. Huh? Yes, of course. Questions? Okay.